So this question 19 from space physics, a toy produces a continuous wave when floating on a surface of a pool of water. The waves spread out in a circular wave pattern. The diagram shows the wavefront produced when the toy is not moving and it is viewed from the top. But then what happened? The diagram 2 shows a wavefront produced when the toy is moving across the surface. Draw an arrow on diagram to show the direction of a motion of a toy. Which direction it is moving? Look, we know that the distance between, yeah, that's right. The distance between the two successive wavefronts is representing a wavelength. So if a toy will move towards A, you can see the spacing between the wavefront is decreasing. It means whenever object or source or observer move towards each other, whenever source or observer will move towards each other, what will happen? The wavelength or the spacing between the wave will decrease and the frequency will increase. And here what happened, you can see the gap between the wavefronts. The gap between the wavefronts is increasing. It means the wavelength is increasing and the number of the wave reaches per second is decreasing. So that's right, it is moving towards A or towards right. So if a person is observing from A, what shift he will receive, a blue or a red?
Blue shift.
So he will experience a blue shift. And an observer at B, what he will observe?
Red shift.
Red.
So he will observe a red shift. The next is explain how the frequency of a wave at point A is different to a frequency of a wave at point B. And 4 marks you have to mention which one is higher frequency.
Round A.
So A is higher frequency than B. And A is shorter wavelength. Then B. But the speed at which the wave is traveling, that is same for both. So speed of a wave moving towards A is same as speed of wave moving towards B. So both will have the same speed because what happened? We have the formula V is equals to F lambda. So for A, the frequency increases, but the wavelength decreases. And for B, the frequency decrease, but the wavelength increased. And the product of these two will be constant. So speed will be constant. So the mark distribution is comparison of the frequency, like A higher frequency than B, A shorter wavelength than B, A and B are moving with the same speed. And how you can say that? Because for A, if the frequency increase, the wavelength decrease. And for B, the frequency decreased, but the wavelength has increased. So question 20 is actually related to give 2 pieces of evidence for a Big Bang theory. Like, what are the evidence?
Red shift is being experienced.
Can you repeat what you said?
Red shift is being experienced.
Of what? You have to mention cosmological background radiation or cosmological redshift is experienced, or cosmic microwaves or CMBR, the cosmic microwave background radiation, this shows a redshift, which is an evidence that the universe is that like it all started with a Big Bang, like all was one point or a point of singularity, and then these particles, astronomical objects, as they move away from each other, they are emitting out different types of microwaves. So these microwaves which are emitted out in the past and present, we find there is a change in the wavelength, which give an evidence that for a Big Bang, like it all started with 1 point. So give two pieces of evidence of Big Bang Theory. Number one, the first evidence that we have the cosmic background radiations or cosmic microwave background radiation. And it shows redshift. Yeah, actually, it is in the order of a microwave. It is emitting out other radiation as well. It is emitting out visible light as well. There are infrared as well, but most of the cosmic background radiation are in a range or order of a microwave. The red arrow is representing a wave which is traveling from source of a background radiation towards us, example. So what is emitted out from the source and what we receive a longer wavelength as compared to emit out from a source. So give an idea that it all started with a big bang, and this is what a Big Bang theory is, that it all started with a point of singularity. How this evidence support the Big Bang theory? Like two pieces of evidence are there that we have a background radiation, and the second thing, it's a red shift is giving out, or it is giving a red shift. So first thing, that this cosmic background radiation, like say we are here. So amount of cosmic background radiation which we receive from different parts is almost same. That is one thing. And the wavelength which we receive from this cosmic background radiation or cosmic microwave background radiation, that the wavelength appear to be longer. So shows that these particles or these sources which are responsible for the background radiation are moving away from us. That's why what we receive on Earth. So because if something starts with a big bang or explosion, to conserve a momentum, if one particle move towards right, one particle will move towards left. If one particle move upward, one particle move downward. That's why, like example, this is a source of cosmic background radiation. So all these sources are emitting out cosmic background radiation, and we receive same amount of radiation, almost same amount of radiation throughout. So this give an idea, because if something explode, it conserve the momentum, it will explode in a symmetry. That's why if it was not a big bang, like example, if say this was a single point and the universe does not start with a big bang, so there might be a possibility that one side we will receive more background radiation than the other side. But what happened, how it support the Big Bang theory, like the cosmic background radiation? Because when we are observing these cosmic background radiation, we receive same amount from all the sides, approximately. So what is an evidence? This evidence that it all started with an explosion. Like it was 1 point, and then when it explode uniformly. Conserve the momentum. That's why we receive the same amount of radiation. And second thing, evidence that the wavelength is increasing, a redshift is there, a Doppler shift, a redshift, which shows that these all particles are moving away from us. So which also give an evidence like a Big Bang, like support a Big Bang theory that started with an explosion and the things just scattered or move away from each other. So the points which we will mention, number one, the cosmic microwave background radiation are same in all direction. Appear to be same in all direction, and which implies that the universe in contact, or it explode and just scattered into the surrounding. That is one thing. And the wavelength increases. shows universe has expanded, and initially the universe was relatively hotter, but now what we receive a longer wavelength. So is it clear, this part?
Yes, sir, clear.
Why we are saying the universe was hotter long ago? Because the wavelength is increasing. Like, say this we are observing the sources of the background radiation. Maybe in the beginning it was giving an infrared radiation, but now what we receive a micro. So in an electromagnetic spectrum, yeah, it keep getting colder as it expands. That is right. And why we say the universe was hotter? Because we have radio wave, we have microwave, we have infrared radiation, the visible, the part which we can see. We have ultraviolet, UV, we have X-rays and gamma. So maybe the universe initially was so hot, it was emitting out infrared radiation. But now most of the background radiation are microwave. So if most of them are microwave, what does it mean? It means the wavelength has increased. So if the wavelength has increased, gamma rays, X-rays, they have high energy. So temperature will be higher. But here what happened, radio wave, microwave, the wavelengths are longer. So shows that the universe is like cooling down.